Okay, so here we go. I'm going to do an example. Graph f of x equals log base 3 of x minus 2 plus 1. Now, this is going to work just like quadratics did. If you take the argument x minus 2, set it equal to 0, right? You'll see you get x equals 2. That's your vertical asymptote. Pretty nice, huh? That's your vertical asymptote. Now, you can't evaluate log of 2 minus 2 like you could with the vertex because it's an asymptote. You can't take log of 0, right? So that's how you find the asymptote. The asymptote is where the argument of the log function, the inside of the log function, where that equals 0. Right? You see how this is a theme that keeps coming back again and again? This is why I like to teach this way. It's a good way to remember things. So you get x equals 2. That's the equation of the vertical line that's the asymptote for a logarithm. Okay? Now don't get this confused with exponential functions. With exponential functions, the asymptote would come from the 1 hanging off the end there. It would be right? Because that's y equals something. Y equals 1. But here it's x equals 2. And then I'm just going to solve these equations. And I actually just wrote these out. I don't know why they appeared instantly that way, but I think I hit the wrong button again. Let's see. There we go. Now we can watch me write it out. Isn't that exciting? Okay. So you see what I did? I took the argument x minus 2, and I just wrote it out as 3 different equations, and I'm going to solve for x, and that's the x I'm going to use. This always works. It's a really nice way to do it. So I want x minus 2. I want the argument to be 3 to the minus 1. So, and if that's not clear yet, you'll see in a minute why. So that means that x is going to be 2 plus 1/3. Right, which I could convert to a single fraction if I want. The second one, x minus 2 equals 3 to the 0, and the third one, x minus 2 equals 3 to the 1. The reason I'm picking these is because when I take log base 3 of these, you see, notice how it is a log base 3. When I take log base 3 of each of these numbers, the log base 3 and the 3 in the base here is going to cancel, and I'm just going to get the exponent. I'm going to get minus 1, 1, and 1, which are really nice numbers to graph. So that's why I'm using that. So I'm just solving for what x to use, and I'm going to make a little table like you usually do. You know, a little table like this, and put the x and the y, and then, you know, fill in the numbers. That's what I'm doing here. I'm just picking good numbers to use instead of just using like 1, 2, 3, 4, which is going to be really hard. I just didn't want to do the fractions, so I just wrote it as 2.3 with a bar over it. That's a third, right? And here I've got 2 plus 1, because 3 to the 0 is 1. So there I just get 3. The fact that it's a 3 is a coincidence. Okay. And here I've got 2 plus 3, which is 5. So my inputs I'm going to use are 2 1/3, 3, and 5. Seems kind of odd to use 2 1/3, but the reason I'm doing that is because I can easily evaluate the log base 3. And if I just pick like 1, 2, 3, 4, 5, I can't. All but 3 or 5 I couldn't evaluate very easily. I mean, I'd need more properties of logs to evaluate them. So I'm going to find f of these. That's the y, right? F of 2.3 with a bar over it is log base 3 of 3 to the minus 1. I know that because I already computed it. Right here, right? So I'm taking x minus 2. So I'm just going back to here. So that's why I know it's that right away. Plus 1. So I'm just plugging this in here. You can compute it if you want. 2 1/3 minus 2 is 1/3, which is 3 to the minus 1. Now, why am I writing this as 3 to the minus 1 and not 1/3? Because I want to write this as a power of 3. Because this is base 3, so I want an exponential base 3. So instead of writing 1/3, I write 3 to the minus 1. Then these two cancel, and this here becomes just minus 1. So I get minus 1 plus 1 is 0, see? Which is an integer, which is nice. Okay? So think about that until you got it. Or maybe look at this next one and you'll get it. It's the same for all of them, basically. So if I plug 3 in, I get log of 3 to the 0. What I'm really doing is up here, I'm plugging 3 in. Where am I? I'm plugging 3 in here. So I get 3 log base 3 of 1. 3 minus 2 is 1. Write that as a power of 3. 1 is 3 to the 0 power. That's what that 3 to the 0 is. Then plus 1. Plus 1. This is 0 because the log base 3 and the exponential base 3 cancel and you just get 0. So you get 0 plus 1, which is 1. Okay? And then the next one, I'm going to use this green one right there. Take f of 5. So that's going to be log base 3 of 3, right? You put 5 in here. 5 minus 2 is 3. So you'll have 3 to the 1. You're writing 3 as a power of 1. Then the 3 cancels. I'm sorry, you're writing 3 as a power of 3, which is 3 to the 1. Okay, so that's what I did on the next one. So, right? 3 to the 1. So this log base 3 and this 3 here cancel, and you just get 1 here. So you get 1 plus 1. Right? And I colored them so you could tell which one came from where. And that's, of course, 1 plus 1 is 2. So notice the outputs. See, isn't this kind of cute? The outputs are actually consecutive integers. That's just because the way I set them up, because I used consecutive integers here. Minus 1, 0, and 1. And so this part became, see these minus 1, 0, and 1. And all I had to do is add the 1 to it. Okay? So you might have to think about that a little bit to get what I was doing, but it's really important that you get that. And it's also very good for your brain because you're being clever about it rather than just plugging in 1, 2, 3, 4 and then wondering, what's log base 3 of 2? I don't know. How do I graph it? I don't know. I'm stuck. I don't know what to do. Yeah, that's why we don't do it that way. So you can't be lazy about setting these up. Just do it exactly like I did it here. Whatever is inside the log, just set it equal to the base to the minus 1 power, the base to 0, and the base to the first power. Solve for x, right? And then use that for your input. So I need to graph these points, right? So I graphed them, and I put them in the right color so you can see where they are. You see how nice those points are? They're not like way out at 1,000 or something, you know? And I even got the x-intercept. So I just would fill those in. On your homework, they can ask you for 2 or 3 points on the logarithmic, on the graph of the logarithm, and this is exactly how you should do it at this point. Later on, there's some other techniques you can use, but still, if you understand this is actually pretty easy once you understand it. It's just getting to where you understand it. That's the work. and it, where you're able understand it well enough to do it yourself. Okay, so anyway, that's the end of that section. Yay.